Okay, we're going to talk about section 2.4, which is actually, it says the product and quotient rule, but it actually should say the chain rule. So that's a little typo on my part, so all I can say is oops. All right, but here a little warm up. Determine each of the following derivatives. Okay, we use product rule here, and remember, you take the derivative of the first times the second plus the derivative of the second times the first. So we did that. So we got derivative of negative 3x is negative 3, and then times that times x squared plus 1. And then take the derivative of the second, which is 2x times the first, which is negative 3x, and we end up with 9x squared minus 3. And then do the same thing here, derivative of the first times the second, plus the derivative of the second times the first. And that gives us 8x plus 1. All right. Now, for a quotient rule, the denominator squared down here, then the derivative of the top times the bottom minus the derivative of the bottom times the top, which is exactly what we did. And I'm just going to leave it there because there's a lot of algebra there involved, and y'all could do the algebra. So, all right, and that saves us a little time. Okay, now, the chain rule is differentiable function of u, and where u equals g of x is differentiable such that y equals f of g of x is a differentiable function. And I will tell you all how that's going to work here in just a moment. All right. Now, this stuff here is going to sound confusing. But what I'll do is I'll come back, I'll do some examples, then I'll come back and point this out, and maybe it'll make a little bit more sense. Okay, now, the derivative of y in terms of x, that's dy over dx. We've been talking about that for a couple sections now. Well, if you differentiate in terms of u, then you differentiate u in terms of x. Here's what happens. All right. Those two end up canceling out, but that's not going to make a whole lot of sense right now. Now, if you have, and I'm going to show you this, if you have y equals f of g of x, which you've had those functions before, y prime is going to equal f prime g of x times g prime of x. All right, so that there is key. This right here is the same as all of that. And I'm trying to highlight it all, and I'm not doing a very good job of it, but oh well. All right. So this here does not make a whole lot of sense, but if I show you a couple of examples, it might make a little more sense. And we're going to lead up to that here in just a moment. So what we're going to do is we're going to substitute a more complex value for a simpler value like u. So take, for example, I'm going to take this value and I'm going to substitute u in for 2x. So now I have y equals sine of u. You may not think there's a need for it at the moment, but in just a moment, you're going to see what I'm talking about. Okay, now, y equals tangent squared of x. Well, if I set u equal to tangent of x, then that means that y equals tangent of u. It equals tangent of u. All right. Now let's do another one. This time we're going to substitute. We got y equals, and it's not really clear right here, so I'm going to go ahead and rewrite this. Y equals the square root of 3x squared minus x plus 1. All right, well, I'm going to substitute u equals 3x squared minus x plus 1, and then we'll get y equals the square root of u, which is u to the 1/2. Now, I'm going to throw in something else here instead. I'm going to throw in du over dx, the derivative of u in terms of x. So you have dealt with dy over dx. Now we're just doing the derivative of u in terms of x, and that's just simply going to be 6x minus 1. And I'm going to leave that there for a moment. That's not really relevant to this problem, but you're going to see what it is here in just a moment. So I'm going to look at this one. All right. Now, a moment ago, I showed you this function. dy over dx equals dy over du, the derivative of y in terms of u, times the derivative of u in terms of x. So we're going to keep that in the play here. So I'm going to write that up here. dy over du times du over dx. We're going to come to that in just a moment. Okay, now, here's the first thing I'm going to do. I'm going to take this right here. My u is going to be x squared plus 1. Now, my equation y is going to equal u to the third. All right, now, here's what we're talking about. Y prime, in this case, is dy over du, because it's the derivative of y in terms of u, which in this case is 3u to the second. Okay, now, what is the derivative of u in terms of it? So du over dx equals, in this case, 2x squared. Now, here's what I'm going to do. I'm going to substitute back in, and I'm going to take, okay, so that there's less confusion, I'm going to take that part off, y prime. Okay, so here's what I need to know. I need dy over dx equals dy over du times du over dx. Now here's what we have. This value right here is dy over du, that is 3u to the second, times du over dx, which is 2x squared. Excuse me, it's not 2x squared. It is just simply 2x. I should not have written the 2 there, so let me go back and fix that. Okay, so, well, what is u? U, remember, is x to the second plus 1. So it's going to be 3 times x squared plus 1 times 2x. So basically what you have done is you've taken the derivative of this right here times the derivative of what's inside. So it's a two-part derivative, the derivative of the whole and then the derivative of what's inside. That's the part that can kind of be confusing at times. And we're going to do a few more examples of it just so you kind of get the idea of how that works. All right. So, okay, this next part may make this a little bit more easy for you to understand. And if it's confusing, I completely understand it because it confused me the first couple times I learned it. So you're in good. If you're confused, that's perfectly all right. It just takes some practice. All right, now, the derivative in terms of x of u to the n equals, and I'm going to write this out for you, n times u to the, or u of x to the n minus 1 times du over dx. Now, that can be written as the following, and this may make a little more sense to you. So, d derivative in terms of x of u to the n equals, in this case, n times u to the n minus 1 times u prime. So basically, differentiate the outside and then go inside and differentiate that and multiply it together. So, but before you can do all that, you got to figure out what u is. Okay, so let's look at this one. F of x equals 3x squared, or 3x minus 2x squared, all to the third power. Okay, so we'll say y equals 3 times, or 3 3x minus 2x squared is a third. Now, u is going to equal what's inside, which is 3x squared minus 2x squared. And I did it again. I said squared when I shouldn't have, so I apologize for that. That was my fault. So u prime is just a derivative of this, which is 3 minus 4x. All right, so that's u prime, because we differentiate what inside. Now, if we rewrite this as y equals u to the third, well, y prime is going to equal 3u to the second times u prime. Now, here's what all that means. I'm going to take this quantity right here and place it right there. And I'm going to take this quantity right here and place it right there. So now I have 3 times 3x minus 2x squared all to the second times 3 minus 4x. Okay, so here's what we did. To differentiate or take the derivative of this quantity, 3x minus 2x squared all to the third, I differentiated this part and got 3 times this to the second. So the 3 went out front, this stayed the same, and this became the second. But then I came back afterwards and I differentiated what's inside. So that's going to be 3 minus 4x. That's the part that most of you are going to struggle with. It's do the whole and then do the part afterward. All right. Now, I'm going to stop this video. We'll do part 2 here in just a moment. But I want to get a good stopping point since I always run out of time. Here we go. We're going to part 2 in just a moment.